Hello guys, welcome back to the Math Club. This is Paul Ayog, your mathematics instructor. I posted a video the other day and it was an incomplete video. So here is the complete video. So we're giving the integral to evaluate the integral of dx all over x squared multiplied by the root of x squared minus 1. Like I've been saying, when you see equation that has to do with integrating a rational function, the first thing is for us to verify whether the function, the denominator of the rational function can be expressed into partial fraction. If you look at it very well, because of the root sign, this denominator cannot be expressed into partial fraction. So we cannot decompose it into partial fraction. Secondly, we cannot complete the square of the denominator. So we cannot apply the approach, the completing the square approach. So the only and easier approach to apply here is that of substitution. So we'll proceed by the method of substitution. Now the question is, what type of substitution do we apply here? The type of substitution that to apply here will be such that it will cancel out the square root. Now, if we use hyperbolic cos, something like cos theta, we are going to have cos squared theta minus 1. And cos squared theta minus 1 is sine squared theta. So the square root of sine squared theta will give us sine theta. So you see that using hyperbolic cos will enable us to cancel out the root sign. And we can also use sec theta. So if we use x in the place of sec theta, we are going to have sec squared theta minus 1, which is the identity for tan squared theta. So sec squared theta minus 1 gives us tan squared theta. Then the root and tan squared theta cancel out. So this position of our square root, we are going to have tan theta. That permits us to do away with the square root. So we can use cos theta or sec theta. So I will prefer us to proceed with sine sec theta. Pardon. Okay. So let's proceed by using the identity of sec theta here, which will give us tan squared theta. The root of tan squared theta will give us tan theta. So we say sec squared theta minus 1, sec squared theta minus 1 equal to tan squared theta. So this is the identity that we are going to be using. So we say let sec theta be equal to x, which I can call as equation 1. Now, like I said, when we are using substitution, since our integral with respect to dx, we have to differentiate this relationship so that we can have dx here, which will permit us to replace it here. So I will differentiate sec theta. So the differential of sec theta is sec theta tan theta d theta dx, and the differential of x is 1. So since the objective is to make dx the subject of formula, I will proceed as follows. Sec theta tan theta d theta should be equal to dx. So I just multiply here by dx, I multiply here by dx, since the objective is to replace dx with a relationship here, with this relationship. Okay, so we already have this situation. It means our integral of dx on x squared, the root of x squared minus 1, becomes equal to the integral. So in the position, in the place of the x, I will be replacing sec theta tan theta d theta. All that on here is x squared. So for me to have x squared, I'll square equation 1. So when I square equation 1, I'll have x squared here. When I square this left hand side, I will also have sec squared theta here. So in the place of x squared, I will have sec squared theta and the root of the same thing, the same procedure under the root sign. In the place of x squared, I will square equation 1 to have x squared here. I will also square this left hand side to have sec squared theta minus 1. So let me wide this board so that I can have space. Wide my board so that I can have space. So I have sec, yeah, okay. So that I have sec squared theta minus 1. Now we all realize that sec squared theta minus 1, sec squared theta minus 1 is tan squared theta. So it means this integral becomes the integral of sec theta tan theta d theta on sec squared theta. So this becomes the root, since sec squared theta minus 1 is tan squared theta. Now sec theta cancels with one sec theta here. We are going to have the integral of tan theta d theta divided by sec theta. The root and the square on tan, they cancel out, so we left with tan theta in that position. So tan theta up here cancel with tan theta up here. We are going to have the integral. We're going to be left with the integral of d theta all over sec theta. Now, but sec theta is the same as 1 all over cos theta. Recall that sec theta is the same as 1 all divided by cos theta. So therefore, our integral now becomes the integral of d theta divided by, in the place of sec theta, I'll use 1 on cos theta. Now, because of the division sign, and we have 1 all over cos theta at the denominator, we are going to invert. So when we invert, cos go up, it becomes cos theta d theta. Now, the integral of cos theta is sin theta. So the integral of cos theta d theta is equal to sin theta plus k. Now, some students will end at this level, thinking that they have arrived at the final integral. No, it will be wrong, because you are integrating with respect to x and not with respect to theta. So we need to come back and replace sin theta with a relationship that contains x. And how are we going to do that? Equation 1 is going to do the job for us. So I will say, using equation 1, this equation, we know that sec theta is 1 all over cos theta, which is equal to x. The objective is to obtain a relationship between sine and x so that I can replace it here. And how do I do that? I have to square. So squaring both sides, I'll have 1 all over cos theta squared should be equal to x squared. So 1 all over cos squared theta will be equal to x squared. From there, I see that when you cross multiply, you see that 1 all over x squared is equal to cos squared theta. Now, but we know the identity of cos squared theta in terms of sin squared theta. We know that 1 all over x squared, 1 all over x squared is the same as cos squared theta is the same as 1 minus sin squared theta. Now from there we can make sin theta the subject. So we just take sin squared theta this way. It becomes sin squared theta equal 1 minus 1 all over x squared. From there we have sin squared theta equal, we are going to express this as a single fraction. It will give us x squared minus 1 all over x squared. Now when we take the square root on both sides so that we can have a relationship of sin theta, we're going to have sin theta equal to the root of x squared minus 1, all that divided by x squared. So from there, you see that sin theta will actually be equal to this. The square root on the numerator and the square root on the denominator will give us the root of x squared minus 1, all that divided by x. So therefore, the integral of dx all on x squared times the root of x squared minus 1 is actually equal to the root of x squared minus 1 all on x plus k, because this expression has been replaced. It has been replaced actually in the place of sine theta. So if you look at, I have replaced this expression in the place of sine theta. So this is the actual integral. So ladies and gentlemen, you can follow me on TikTok, on YouTube, on Facebook, and on Instagram. I am going to be posting very interesting content in mathematics. I'm going to also be organizing a lot of live sessions. So subscribe, share my videos, because the videos might help others to understand some basic concepts in mathematics and improve their skills. Thank you.